Okay, it's time to move to next session. Next session will be next session 3, ICT for secure and smart community. This session will be chaired by Guan-Tan Tu, Professor Guan-Tan Tu from VNU. Professor
Thank you so much.
Guan-Tan Tu, can you hear me?
Yes. Thank you so much, Dr. Emoto Hiroshi.
Thank you. Please.
Good morning, ASEAN IVO steering committee members. Good morning, presenters. We have now 4 working presentation in the section. First, I would like to invite Dr. Philip Abela Martinez from the Philippines to present RuralSync, providing digital content in remote communities through opportunistic spectrum access. Please.
Are you now? Yeah, I'm sharing the screen. Okay. Mabuhay from the Philippines. I am Philip Martinez from the DOST, Advanced Science and Technology Institute of the Philippines, and I am here to present going efforts in entitled RuralSync.
Yeah,
sorry.
Yes.
Providing digital content in remote communities through opportunistic spectrum access. So the rationale for this efforts is due to the pandemic situation, in-person classes here in the Philippines are still limited and has abruptly shifted to remote mode of delivery. However, in the setup, there are still unserved and underserved areas in the Philippines where information infrastructure is unavailable or unreliable. To address this digital divide, the project investigates the use of wireless technologies operating on TV broadcast signals to deliver educational materials in remote and rural communities. And we have chosen to explore in UHF TV frequencies because it is known to reach farther distances compared to other frequency bands. So let us discuss ISDBT datacasting. ISDBT is the digital TV standard adopted by the Philippines. We are currently on test broadcast, meaning we have both analog and digital TV transmission operating at the same time. But analog shut-off is scheduled by 2023. And by analog shut-off, we have an opportunity to use the vacated frequencies for other applications. And we see this as an opportunity to explore datacasting, which is a way to send auxiliary files apart from the broadcast material. To tell you more about this, let us imagine the digital TV transmission as a data pipe wherein you have your video, your audio, and some null packets for to maintain the constant bitrate. We maximize the unused capacity by using this data by inserting useful data packets. This could be packets containing modules for the lessons that is synced with the video and audio content for broadcast. So here is our test setup. We have the video and audio encoder. Then we have multimedia in the form of a text file or a PDF file that is inside theoretically in a file database, and it is carried into a object carousel, and it is then transported into a transport stream via a multiplexer. So the normal multiplexed for broadcast is only audio and video, but now we are inserting multimedia and text, etc. in an object carousel. This modified transport stream is then received by the the DTV receiver, which is connected to a single board computer for processing of the received transport stream to be able to show the content for broadcast and to capture the sent data that is sent through the transport stream. So again, it's generate the transport stream with audio, video, and data. Transmit for now using an SDR-based transmitter, but this setup could be modified into scale to use other transmitters as well. But for now, it's SDR for the proof of concept. Then we receive the transport stream to the DTV receiver and retrieve the sent data. So here is the developed ISDBT transmitter prototype. It is an SDR-based transmitter prototype with one segment channel transmission plus 12 full segment transmission. It is operating at 10 watts peak output and complies with the necessary modulation for ISDBT, which is 64 QAM, 16 QAM, QPSK, and the various bitrate depending on the modulation scheme. You can see the picture of the setup of the transmitter, the INQ plots, and the ISDBT constellation plot. Here is the ISDBT receiver prototype developed by DOST-ASTI. It is an integrated tuner which tunes into the RF frequency and to lock into the certain program for that is being broadcasted by the transmitter, and it is it's integrated with the modulator to transform this transport stream into an MPEG file format, and it has a USB interface to be connected to the computer for the processing of the MPEG file and for actually control of the tuner. So the picture on the left is the said board in action. It receives a transmission broadcast, educational file that is being broadcast, and the receiver is connected into a laptop which simulates a single board for us to just see if the tuner is able to tune and to able to convert the transport stream into something that is viewable, like the picture that you are seeing right now. So we also have some preliminary testing since we both have the transmitter prototype and the receiver prototype. So the scenario here is that because we are limited with the transmit channels that we can actually use, because in the urban areas we cannot use the TV channels. So we are testing this in a rural area where there is no TV transmission, apparent TV transmission. And the scenario is that we have a low power transmitter located in the school to simulate situation wherein the school itself is a broadcasting station wherein the community can tune into those the programs being transmitted at the school. So, and we are measuring the signal strength and confirm reception of the stream and attempt to retrieve a PDF file that is embedded into the transport stream, which is 6 MB in size. So you can see the picture from the transmit side and from the receive side. So due to the limitations of our testing, we only have distances from 0 to 100 meters. So from the transmit side, that's your antenna, and from the receive side, you can see us measuring the receive signal strength and the confirmation of the reception stream. So preliminary result, to receive the stream and retrieve a 6 MB PDF file at 80 meters away from the transmitter. So the figure on the right is the level of the data. It is around negative 50 dBm. For this project is to test other kinds of file formats and different file sizes. More test scenario, just a more of would like to test more the broadcast language and work on an improved and integrated receiver device wherein a computer is integrated into the tuner and the modulator board. And that ends my presentation. Thank you. And the floor is now open for your questions. Thank you very much. And again, mabuhay from the Philippines and stay safe wherever you are.
Thank you, Mr. Philip Martinez. And it's time for us to have questions, please. Yes, Dr. Rahman. I have one question.
Sir.
Your solution is very interesting for the developing countries based on the ISDBT,
Sir.
the casting.
Sir. Yes.
And how much does it cost? The package including ISDBT transmitter and receiver antenna. Can you?
Because we are in the prototyping process,
can you
the costs
estimate?
are initially high. It is around the actual cost for the prototype itself. I guess it's just remember it's a prototype, so the costs are high. It ranges from 20,000 pesos for now, but
equivalent to dollars.
Because sorry, times divide by around 250 to 300.
Oh, it's good. It's good. Yeah. Thank you. And it's time for more questions, please.
Hi, Alyssa from NICTEC. Can I ask, have a question?
Ashin.
I'm just wondering, have you talked to, like for the sustainability, have you talked to maybe the Department of Education, the Ministry of Education, or I'm not sure, the Ministry of Telecommunication, for them to maybe after the project, they can sort of like subsidize or endorse this type of equipment, to make it more sustainable?
Yes, we have considered partnering with our Department of Education and for our National Telecommunications Commission, which is the our FCC in the Philippines, in order for this project to be developed further and to introduce them that we are developing these efforts. And actually, we have initial meetings with the school and the Department of Education, and we are actually partnering with them to test the contents that they have, because they have the video contents already, and they just have to distribute it in the this remote area. So we are currently talking with them and exploring the synergies for us, because we believe that this is a great project that will help our Department of Education to reach more students and to have an interactive experience in the remote delivery of learning.
Thank you very much.
Okay, I have one question, Mr. Philip.
Sir?
Can you hear me here?
Yes, sir.
Okay, I didn't see any collaborators in your presentation, right?
Yes, sir.
So what is the what do you think about the potential impacts on the Asian countries, based on your project?
Sir, because we share the same situation in ASEAN, I think we could partner with other ASEAN countries as well. And the only difference is that the technologies of the digital TV that has been adopted is different by other countries. And I think it is Philippines and Cambodia that has adopted ISDBT, and other countries have adopted other standards which may or may not support data casting. But the technology or the algorithms would be similar as well. So we could we could forge, and we are open to partnerships with other countries as well. Or if there are other ASEAN countries that has started with data casting as a form of educational delivery, then we are open to have meetings and collaborations with other countries as well. Yes, sir.
Okay, thank you.
We have 1 more minute for question, please. Very short questions.
Okay, Philip, have you any supporting funds for your project?
Okay.
Currently, sir, the project is currently supported by the Philippine government as of now, and we are looking for other funding sources as well to have more developments in this area, sir.
Okay, thank you, Chairman.
Okay, thank you, Mr. Phyllis Martinez. Good.
Thank you, sir.
Good success. Thank you. And now, next, I would like to invite Dr. Sai Long Keoh from Singapore, University of Glasgow, Singapore, to present an IoT-based public transformation
Excuse me.
framework.
Excuse me.
Sorry. Okay.
We would like to take a picture, a group picture for this session. So could the people involved in this session please turn on their cameras so that the Secretariat can get a group photo? Thank you.
Thank you.
Right, thank you. Thank you very much. We may proceed with the presentation.
Thank you so much. And let me to invite Dr. Sai Long Keoh from University of Glasgow, Singapore, to present an IoT-based public transport data collection framework using Bluetooth proximity beacons. Please.
Thank you, Chairperson. I'm Sai Long from University of Glasgow, UK, but actually based in Singapore. So today I'm going to share my experience, our project experience on using IoT systems to actually collect public transport data using Bluetooth proximity beacons to collect bus data sets for analysis. So this is a brief outline of my talk today. So what are the problems, definitions, how do we actually can use technology to actually improve the urban mobilities, especially for developing countries. And then we'll present our sharing of our prototypes on using IoT-based bus tracking systems, our deployment experience and insight, and how we can actually work together with some of the partners in ASEAN, to make an impact, and what are the potential future works and collaborations. So I think this is a very typical scenes that you can see in many developing countries where people were waiting for bus services at the bus stop, primarily because the bus schedules are not really accurate, not like in Japan or in European countries or even in Singapore. Buses schedules are pretty accurate, and the waiting time is quite minimal. But in majority of the developing countries, we have these problems where people may not know what time the buses will arrive, and how can we actually use technology to improve such a situation. So these are some of the pictures that we've taken in Johor, Malaysia. I'm personally from Malaysia, so although I work in Singapore, and sometimes I go back to Johor, and then this is some of the scenes that I've seen in Malaysia, as well as in KL, even though there's a bus, its estimated arrival time dashboard available, but I think most of the times it's not accurate, say. And if you look at this further, there are many developing countries around the world which may not have the necessity, technology or costs or fundings to actually improve the public infrastructures, especially for the public transport systems, right? So I think majority of the ASEAN countries as well are classified as developing countries where economies are in transition, and then some of this technology can actually help to alleviate problems faced by the commuters at large. In particular, what we observe currently is that majority or most of the countries in developing countries, they prefer to purchase new bus fleets, in terms of hardware, right? In terms of software infrastructure investments, we see that there's a lack of software infrastructure investment in such situation, right? In rural areas in particular, bus frequency is considered very low. You may need to wait for a long time, for the bus to arrive. Sometimes you may not even have bus drivers coming to work, right? And that ensures that the users are not really, they don't really know when the bus will arrive, and sometimes it may not even arrive, right? So when we speak to the bus operators in Johor, for example, the operator also mentioned that there's lack of bus driver because there are certain regulations by the governments that the bus drivers should be citizens of the countries, and they can't really employ foreigners to actually work as a bus driver. Okay. So of course, in terms of the accuracy, the scheduling, the service quality is actually not so good, compared to the developed countries. So, for example, if the bus driver call in 6, and then the bus service may be disrupted, and especially for those serving the rural areas. So what we did actually is we partnered with a bus operator in Johor just to test service routes between Kulai and Johor Bahru. So we were working with a very small bus operator in Johor that doesn't have any software infrastructure in place. They only run the bus fleets. So it's a very competitive route actually between Kulai and Johor Bahru. There are many bus operators. There are also free buses provided by the government. But all of these buses, majority of them, they don't have a software infrastructure to provide estimated time of arrival. So the bus drivers, the bus operator also mentioned that it's actually quite expensive for them to invest in the infrastructure. For example, to install software system, cloud systems, or even GPS real-time systems for bus fleet tracking and bus arrival information. So this is the second versions of the implementation that we actually worked on or deployed. So we actually use IoT-based systems that use Bluetooth beacons as the way or methods to detect bus at the bus stop, and we also use Raspberry Pi devices connected with 3G connectivities. And then with the Bluetooth chip on board a Raspberry Pi, when the bus arrived at the bus stop, we were able to detect that the bus actually arrived at the bus stop. Then we can then track, in some granularity, the location of the bus. Now, of course, we'll need a cloud platform to actually process the data and then provide the analysis. So this is the first step towards data collections, and later on, we can then use the data collected to actually perform analytics or even bus arrival prediction in the future. So this is the architectures that we actually implemented and deployed. So we actually, as I mentioned, we only experimented with one bus service route between Kulai and Johor Bahru. So we actually fitted a Raspberry Pi at the bus stops or even some shop houses along the route, right? So that when the bus passes by the bus stops, Bluetooth detection will be able to detect, the beacons we put inside the bus itself, right? So this actually alleviates, the cost investment by the bus operators, because we just need to put a Bluetooth beacon inside the bus instead of installing a GPS device on the bus together with a 3G connection that constantly send a location update to the cloud services, right? So so we have a Raspberry Pi deployed at the bus stop, and then the bus stop location will be detected if the bus is in proximity. And then via the 3G connection, we send to the cloud for analytics, right? And at the same time, we can then, compute or even analyze the bus arrival time along the route in the future towards the destination along the service route. Okay. So we also developed a simple mobile app, with the mobile with the map illustrating the location of the bus stops, the estimated arrival time. And of course, then there's no funding for this project currently, and that's why we actually rely a bit on the Google advertisements to it. But I think it's just a prototype that we wanted to experiment, an alternative way to do data collection, because some of the GPS traces may not be available for us to actually analyze the data, because I think most of the bus operator will claim that data is private and that they do not want to share the data with us. So for the field trial and deployment, this is actually a bus stop opposite the Kulai Hospital, in Kulai. So we fitted a Raspberry Pi here, right? And then we actually had to rent a power supply from the shop at the bus stops. Of course, we equipped with the 3G connectivities, and then that will be able to detect the bus when bus arrive. So if you look at a video here, just to give you some sense of the accuracy of the bus arrival time, the user can actually check the mobile app to check when the bus will arrive. But we didn't actually manage to do a info panel at the bus stop because this will require the cooperation from the city councils, which we haven't really got a chance to speak to them. So it's actually a field trial deployment together with the operators in this case. So if for this particular deployment, we actually only fitted 3 Raspberry Pi. So one before the Pulau final terminals, and then one at the Johor Bahru bus station, central station, JV Central. So we actually fitted in one of the grocery stores or convenience store, and then one in the middle, right? So we ideally we should actually fit most of the Raspberry Pi along the route so that we have a more accurate location detection of the buses. But I think it takes time to actually speak to the owners or city council to fit this for deployments. So we also tested a bit on the in terms of the detection range for the buses, for the Bluetooth beacons, right? So depending on the transmission power of the beacons that we put inside the bus, it's actually quite accurate for the detection. So we can say that we can actually detect the beacons about 90% and above for distance which is less than about 10 meters. So which means that we can detect on this side of the road as well as the opposite side of the road. Sometimes also depending on the speed of the bus, right, the drivers, and also whether the bus driver will stop at the bus stop. So if the bus driver stop at the bus stop, then it's actually quite easy for us to detect. But if the bus driver behave normally, for the upcoming so we can also do crowd level detection on the bus as well. For example, right? So of course, the challenges we face. I think we are looking forward to a council with the bus operators, with also researchers. So maybe we do this together in Malaysia or in ASEAN. So thank you for your attention. Forward to your questions. Thank you.
Thank you, Mr. Ceylon Keoh, for the interesting presentation. And it's time for us to have questions, please.
Okay, thank you, Dr. Ceylon. I think quite interesting. You know why? Why it is interesting?
Me.
Yeah, because you are from the University of Singapore, and then you are trying to solve the problem in Johor.
Yes, from Johor.
Okay, University in Johor.
Singapore, actually.
Oh, in Johor. Okay, I think this work is very good. And, work together with the municipal. They will pick up. Maybe on you. If they're really good, they can. I think maybe we can, because you are you have no collaborators yet. So then maybe you can work together with. Sure. Maybe we can have a matching grant if possible, we can.
I also graduated from UTM in computing science. So it would be good to collaborate.
So very interesting. It's very interesting. Maybe we can contact me. It can. Yeah. This one involved. I think we have to work together with the municipal, council. Otherwise, no point. Yeah. Yes. Okay. That's my question.
Thank you very much. Thank you.
Thank you, Professor Abu Samad. We will success some cooperation. And we have some times for question, please.
I have also a question. My question is, are you actually creating this project from scratch?
Yes, actually, we started with a crowdsource mechanism.
Because
so that time, we actually
because there are a lot of existing companies and marketing solutions, market solution, like, for example, I work with IVO traffic technology as I was at UTM, computer science, and they also have some kind of solution for this one, right?
Yeah, sure.
I was also in from 2011 until 2017. So
yeah, I left already. I think
UTM, you mean?
It was until 2001. Yeah.
Dr. Tony?
Right. Yeah.
Oh,
Beg your pardon?
you said you were working in UTM from
in computer science 2011 until 2017. Professor Wanasya is a good friend of mine. Okay. I have another question. So you mentioned that you work together with a bus operator. May I know which bus operator you're talking about?
So we work with the SNS.
Oh, SNS, not Handal Indah, right?
No, Handal Indah has their own mobile app, and they also have
yeah, that's why I knew they have their own solution.
And always they have their own systems,
right.
But whether they're willing to share the assets, we are not sure. So we're actually targeting a very small operator that don't have the infrastructure, and this will be able to provide, estimation for especially the rural areas where all the smart operators are working, and then it's actually quite low cost for them, so they don't have to fit all the 3G SIM card on buses, and they have to pay it.
Right. Very good. Like some collaborator, I would also be interested in this because I work with Aachen in Germany. The company is called IVO Traffic and Technologies, right? Okay.
Sure.
Thank you very much.
Thank you.
Thank you, Professor Tony Awar.
Yeah, thank you.
Professor
Nguyen.
Thank you once again, Dr.
Can I have a question?
Yes, please.
Very short question, please. Professor Van, please. Very short one.
Yes, very short question. Thank you for I think your movement. It's very interesting. However, I think it's Bluetooth is one way you use. Do you use another way for transmission? Because sometimes the transmission is not very consistent. Let's say, for example, Zigbee or another way you can use because you Raspberry 3, right?
I think currently Zigbee is not supported on Raspberry Pi, right? So the Raspberry Pi itself only support Bluetooth and Wi-Fi. Yeah, so I think that's why we didn't actually use Zigbee. Zigbee you will need a hub actually to do it, and there isn't any Zigbee devices that I can actually put on the bus. I think Bluetooth beacons are pretty much available from the market. You can just purchase off the shelf and fit it onto the bus easily. That's the reason.
Okay, thank you, Professor Van, and thank you, Dr. Loong.
Thanks for your insights and
very interesting
collaboration
presentation. And now I would like to invite Professor Van-Phuc from Liquido University of Vietnam to present the AI-powered comprehensive cyber-physical security for smart cities. Please.
Yes, thank you, Professor Nguyễn Thuy. So now can you see my slide?
Yes.
So I would like to present our proposal in the project with the title IIPOSC, mean Artificial Intelligence Power Comprehensive Cyber Physical Security for Smart City. With I present it on behalf of my group with the partner from my university, from DNU, from University of Educational Communication in Japan, from Songkla University in Thailand, and the NTU and NUS from Singapore. So I would like to talk about the background for our proposal that recently, so the security issue against IoT, the attack against IoT device have become a serious issue in Vietnam and other countries. So in the report from Vietnam, that 70% of IoT devices in Vietnam are under vulnerable, right? So at the developing country, other country in ASEAN is facing the same problem. So the target of our proposal is that we propose a solution for the hardware security issue in the IoT system for smart city, and we would like to contribute to build the research capability of the ASEAN institution in the field of hardware security for IoT. So we would like to establish the link for the researcher, and also not only in ASEAN, but also with the partner from Japan, from Europe, for the hardware security field. So as you know that in the IoT system, the number of nodes is very huge, so that the security and privacy is very important, especially now in the time of COVID-19 pandemic. So the cybersecurity issue become more serious, and the recent development of the artificial technologies and techniques can provide some efficient tool for hardware security implementation and also evaluation. So this is the general architecture for the secure IoT system, from the physical level, like the hardware design for IoT nodes, and in the gateway level, and also in the application level. So in this proposal, we would like to implement the security solution for multi-level, like from the hardware to the gateway, like the ADS or anomaly detection, and in the application level. So for the physical designs in the IoT node, we already designed some parts. So it is the general structure for the secure IoT node design. We combine with some type of technique for the hardware security, like in the hardware design, we combine some cryptography design for, and the PUB design. PUB means the physical unclonable function. It's used for authentication in the IoT system, and we use some open source secure MCU for the control of the system, and we combine with the TE. We mean the trusted execution environment for the IoT platform. And we have achieved some preliminary results. For example, we have developed the deep learning techniques for side channel attack to evaluate the security level of the AES cryptography 4. So we have published in the RSUB APC case in last year. In this technique, we propose some reprocessing technique to reduce the number of required power trace for attack. In this attack, we use the power consumption information to attack the hardware AS core. So by using the technique, we can reduce the number of power trace. And in the gateway level, we have research on the intrusion detection system to deploy the detection method in the gateway level. So because the IoT system is implemented on the very low cost and low complexity and low hardware resource system, so that we would like to provide the lightweight method, like we try to reduce the number of parameters and number of operation in the detection methods by we do pruning, like we adjust the network, the machine learning networks to reduce complexity, So, for example, in this pre-publication, we have already reduced the number of parameter and operation by 90 times, but we can get the same performance with the other techniques. And in the next step, we will implement this method in the hardware that we can employ for the IoT system. And also, we already developed the method to detect the hardware chosen in the IoT system. We very familiar with the concept of software chosen, but in the hardware design, the chosen can also be inserted in the design. So, for example, we had the experiments with the chip, the original chip. We call the clean chip in the left side, and the chip with hardware chosen in the right side. We insert the hardware chosen. Hardware chosen can store the information, and we can leak the information from the system. And then we use the electromagnetic probe to do the scanning over the chip surface and get the side information. And we do some experiments here like that. We have the security evaluation board. We get the result that we can detect with the accuracy of 95%. And the next step, we can apply some deep learning techniques so that we can improve the efficiency. And also for the IoT node design, we have implement the PUB in FPGA and the secure IoT node design with rich file processor with research from Conca from UBC. We already make some chip for this methods. And for the merits of this proposal, that we can provide some guidelines for using the deep learning and AI for hacker security and IoT system, and we try to contribute to the standardization for the system, so we can publish some journal together. And for the impact in ASEAN country, so at the developing countries, so the requirement for IoT device and system become very large now. So we will employ the research result in the reality. So for the methods, we will combine with the theory method, and then we use the simulation, and then implement in hardware, and we will employ in the real system. So for the content, we will divide the process into 4 packages, like the server management, survey and subscription, and demonstration. And we also can get the funding from LQDTU Technical University, and we have already collect with many partners from Vietnam, from BNU, from NICT, and EBC in Japan, in Thailand, Singapore, and also in UK, from some ministry from ICT in Vietnam. So we hope that we can get some more collaboration by this forum. Thank you very much.
Thank you, Professor Van-Phuc, for presentation. And it's time for us to have question, please. I have a question.
Yes.
You are concerning the DL, the deep learning based SCA, and also the deep learning based IDS, and then you are concluding with hardware Trojan detection. What is the connection between the two issues presented above and the hardware Trojan detection concerned by your project?
Yes, as we have seen in this structure, so in our proposal, we would like to do multiple techniques for multiple level in the IoT system. For the hardware chosen detection technique, we apply in the physical level, like we will scan and detect in the hardware module for the IoT system, and for the IDS and other higher level, we will deploy. Okay. So we will attach the. We will use some algorithm in the gateway level to detect the intrusion attacks. And for the hardware chosen detection, we will employ in the physical design. So we employ in the device the practice the device. Yeah.
Okay. And what does it mean SCA? SCA, what does it mean? Security?
SCA means the side channel attack. It means that for the
okay, side channel attack.
Side channel, because they can use some other channel like the power consumption, sound, and some EM. Yes.
Thank you. You have we have some questions, please.
Yeah, I have a question. Hi, Prof. I wanted to ask, you are running the side channel attacks, and are you trying to use a TEE to actually do the protection? And did you actually run the side channel attacks on TEE itself? And what is the preliminary insight? Whether TEE is sufficient enough to protect against side channel attacks?
Yeah, actually, now we do the two independent research component. SCA and TE. Now we not yet employ the side channel attack resistance in TE. Just now we employ TE the basic TE design. So in the next step from now we discussion with the Hong from EVC to combine the SCA prevention with the TE. So I think it's your question is very nice question. So we will employ this one.
Will you also be considering SGX, Intel SGX?
Sorry,
Intel SGX.
Intel SGX?
Yes. So it's also an example of TE, but it's provided by Intel.
Yeah, we have concern some TE architecture from NPM or other providers. So, but now we just use the baseline TE. So we not, because we use the rich file processor, not the processor from Keoh, so that we use another platform.
Thank you so much, Professor Van-Phuc, for interesting presentation.
Yes, thank you very much.
Thank you. And now the last presentation in our session, I'd like to invite Dr. Didi Rosiyadi from Indonesia to present a trusted multimedia content protection scheme based on hybrid watermarking and blockchain model. Please.
Okay, thank you very much. Thank you. I would like to present about the trusted multimedia content protection scheme based on hybrid watermarking and blockchain. This is our researcher team. I'm from Research Center for Informatics, National Research and Innovation Agency, and our team from Japan and from Darussalam and from Thailand and from Taiwan. And so I would like to introduce about introduction. For the security, this is the critical in the transmission of digital products and transaction-based service by internet. And so the security issue in this digital product is confidentiality information, authenticity, integrity, and authority, etc. And so for digital watermarking and blockchain technology, this is a new technology that protect the integrity of digital information and safeguard intellectual property rights. And then what is the digital watermarking technique? So I have three kinds of the digital watermarking for the copyright and so for the access control and authentication. And for the copyright, we can to use this to protect the copyright of the digital product. And so in the access control, we can to protect the access control of the digital product. And the third is for the authentication. We can to protect the authentication of the digital product. And so the often we can to get the digital watermarking technique for robust, private, and semi-private. And then correlated with the blockchain, we have the blockchain and blockchain technology. In the blockchain, this is an essential and an emerging technology as an open distributed ledger or database that record or transaction details. This is the blocks, and so its record is tamed and correlated to the previous blocks and robust to modification of data and to be trusted for transaction between two entities in an efficient and variable manner. And then essentially blockchain is relevant to anything that requires transaction verification or a signature leading to authenticity and trust. And so from the reference one, they propose a novel watermarking based multimedia blockchain framework which uses a cryptographic hash and image hash to decipher retrieval original media contents. And so we use the blockchain technology on a distributed ledger technology, domain allowing transaction to function in a decentralized system, such as allowing transaction to be verified without a central organization to process the transaction. And this technology has main potential usage, transferring any digital content. And then this is the feature for the privacy data and blockchain using homomorphic encryption for image watermarking. So for example, we have the client, and so there is a secure watermarking. We use the encryption. From encryption, we have the blockchain network. This is the blockchain network. And so we have the authorized provider. They can to the watermark provider and then have the encrypted watermark. And so in the blockchain network, we have the smart contract and we use the cloud server. And so we can the last step for this for the process is the description process. This is we get the data and information where the client is receiving. And then for the media contents, we have the this is the artwork with the right information, such as author, date, location, right order, etc. And so all the artworks, right information are included in the image data. So we use the hybrid of DCT and DD. And so for the third process, we have the process apply the DCT. And so for the fourth step, we have the extraction process. And so the last step is perimeter result. And then this is the illustration for the multimedia blockchain process. We have, for example, we have the host image. So we use the process for compressed sensing. And so we use the invisible watermark image. We have in the digital watermark technology, we have two types of the watermark. This is the invisible and visible. And we have the multimedia blockchain for the media transfer. After that, we obtain the watermark image. So we have the updated media database server, and the last media database server with blockchain. And so what is the target and implementation? We have the first, we want to get some international journal. We have the 2 scientific paper, and so the second is international proceedings. Perhaps we got the 2 scientific paper, and so we also get the prototype of security system for an application security system. And then the research method, we have 4 steps in this study. The first literature study for the done to obtain corresponding information on digital image watermarking, DCT SPD method and blockchain model. And so the second step is analysis. In the analysis process consists of drilling the users about what the current system does, and so what extra features they want in their new system, and what constraint the new system must satisfy. And so the third process is the design process is done, and to get a robust DCT SPD watermarking. And so the last process, to obtain the performance of the watermarking proposed scheme by the DCT SPD method based on the blockchain model. And then we use the formula in the DCT and SPD. We have the mathematical modeling for to get the robust for the algorithm in the hybrid DCT SPD. And then this is the illustration for optimized hybrid DCT SPD computation. Over the extremely large image, we have the finding the proposed computation will be extremely faster than the convolutional for the extremely image. We use the sums image from the benchmarks for Lena and etc. And then for the library resources and participants, we have the sums researcher for some countries, like from Indonesia, Taiwan, Japan, Malaysia, Thailand, and Brunei Darussalam. And so we have to for the research area, we have some researcher from the countries, like from the Japan, from Professor Terano from the system security, and so from the Malaysia for the data security, and from Thailand from security framework, etc. And so for the budget explanation for the our research for the joint equipment and joint workshop, and then this is the reference. Okay, thank you very much for our presentation.
Thank you, Dr. Didi, Rosiyadi. I would like to invite to have a question, please.
Yeah, I have a question, please.
Yes, please.
Okay, Professor Didi.
Yes.
If I understand it correctly, so you want to do something like digital image copyright protection. Is it correct?
Yes, yes, right. But we use for the digital watermarking.
Okay. You know that there is this technology now. There is this solution for that, which is called non-fungible token.
Yeah, IFS.
NFT.
And yeah, MS.
Yeah, and it is using also blockchain technology.
Yeah.
So how do you want to compete with this technology? Because has been there like 2-3 years already.
Yeah.
And has been used by a lot of people. Even there are certain NFT products which cost already $millions or something like that. So it's already established, yeah, as a standard for digital image protection.
Yeah, thank you, Prof, for your suggestion. In our team, that we want to get some improvement for the algorithm, because I think for the algorithm is we can still to improve every time, and so it is depend to the for the intruder or attacker, and so we in the result for our research is to get the algorithm. The name is the robust algorithm. Like for in the simulation, maybe we can to check the like for the image in the digital watermarking, like for the PSNR values, like the peak signal to noise ratio or the normalized correlation coefficient. But in our research that the main result is to obtain for the robust algorithm for that. And so for the application, maybe we can to implement it for the NFT or another application for that, like that, Professor.
Okay, but still using blockchain, right?
Yes, right.
Okay, thank you.
Okay, welcome.
Could you have some more question, please? We have some minutes for question and answer.
Yeah, I'd like to ask, what is your application that you have in mind to apply for this research?
Mm-hmm.
Okay,
yes.
Thank you. Yeah, okay. And so if I want to describe about our research, I discussed it with our team that I think this research is correlated with the scientific contribution. And so I get the algorithm, the robust algorithm. And so I think for the application, like for the digital watermarking application, like for how to protect the multimedia data, like image or video or audio. And so like we can to develop some application like in the Play Store and like that. And so we can to for the society contribution, we can to develop from the scientific contribution, we can to develop in the implementation for that.
Yeah, that's right. Yeah, would it be possible to include the stakeholder into your proposal?
Yeah, I think in like in Indonesia, because our research area, like from the data protection, we have some stakeholder for that, for the production agency in the multimedia, like for the copyright and authentication, and for the sounds like in the for the stakeholder in our research.
Thank you. Yeah, I think you should include them. Yes, thank you.
Okay.
Thank you, Dr. Didi.
Yes.
Rosiyadi for interesting presentation. And I would like to say that we finished our session. Thank you.
Thank you very much, Professor Nguyễn, Thành, and our speakers for this session.